This is tutorial number 145, and it covers how to calculate coding within Solidworks. Now to start off, open up the part number 145, which I've included on the DVD. So what I'm going to show you in this tutorial is how to calculate the surface area and how to calculate coding for a certain part. So at my job, lots of times we have to calculate coding on a part. So either it's going to be the paint on the part, or if you want to plate a part with a certain kind of metal, you have to calculate the surface area to get kind of like a quote to find out how much it's going to be. So in this tutorial, I'm going to kind of show you just kind of like how you go about and how you do this. So obviously, if you're going to get a coding quote for a certain part, what you're going to have to do is tell them the surface area. So to easily do this, when you have the part, all you have to do is go to Mass Properties and click on it, and it's going to tell you your surface area right here. So right now it's in millimeters, and the surface area is 44,818. So you know that, and say you want to add an extra feature, and you want to find out how much it's going to cost additionally for that coding. So you can remember the number that you just had, write that down, then say that you want to add a fillet on the two sides here. So let's click on fillet and click on these lines. And we're going to be adding a 2mm fillet. Click OK. And then go back to your mass properties and see the difference. So if you click on mass properties, now it's gone to 44,522. So you can see that as you add, or if you change features on the part, it's going to be changing the surface area. So you can see if, whatever the change may be, you can see how much it's going to cost you, how much you're going to save, and just so you know how much like the coding's going to be. Now, right now it's in millimeters. Some people want it in square meters. If they want it in inches, all you have to do is go into Tools, click Options, click Document Properties, and click Units, and you're able to select either meters, centimeters, millimeters, or inches. So it's up to you, whichever way you need to convey the surface area to whoever it is that you're talking to. Most of the time, though, I keep it, usually when I'm doing like a surface area quote for a coding quote, it's usually centimeters, and sometimes if the part's big enough, it's going to be in meters. So that concludes our tutorial on how to calculate coding within SolidWorks. This is tutorial number 146, and it covers how to use the center of gravity feature within SolidWorks. Now to start off, let's open up a new part file. So let's click File, click New, click Part, click OK. So in this tutorial, I'm going to be showing you how to use the center of mass, center of gravity feature, and in the next couple of tutorials, I'm going to show you how to optimize a sketch using this feature, and then optimizing a part using this feature. So to start off, let's create a sketch. So click Sketch, click Rectangle, click any plane, and from the origin, let's create a sketch of a rectangle, or a square, sorry, and let's dimension this to 50 by 50. And just by looking at this, we know in the sketch where the center of gravity or center of mass would be, and it's at 25, 25. Now let's extrude this out 50 millimeters. And now we know that the center of mass or center of gravity would be 25, 25, 25. So now we're going to use the center of gravity feature just to make sure. So let's click the mass properties, and it's going to give you the center of mass, and it's at 25, 25, 25. Now when you use this feature, you'll notice that there's a purple coordinate system, and that center point right there, that is your center of mass or center of gravity. So it's just showing you where the center of mass, center of gravity is, and which directions it's really pointing. Now, we knew where it would be because we kind of set it up like that. Now if you have a more complex part, it's going to do it, and it's going to find the center of mass too. So let's just do one that's a bit more complex. Let's delete the solid, and let's delete the sketch. And then click Sketch, and with the line, click any plane, and just freehand a sketch that you wouldn't know the center of mass or center of gravity where it would be. and just extrude it out the 50 mils. And now calculate the mass property again. Now, in the Z direction, it's going to be the same as it's only extruded out 50 mils, but the X and the Y are different. And now if you notice that our X, Y, and Z, the coordinate system, the purple one, it's in a different position, and it's also kind of slanted. Now it's slanted just trying to kind of show where this object, where the center of gravity and where the center of mass is really pointing. So by using this tool, we're able to see where exactly to pinpoint the point of the center of mass or center of gravity of an object, and also to see where it's kind of leaning more towards if it was to be tipped and kind of moved around. Now you can use this tool either on a part alone or a whole assembly. So if you have a whole assembly and you put all your components into it, you're able to click it and see where in your assembly the center of mass or center of gravity would be. Now, when you're doing this, you have to make sure that you're using it on a solid or something. You can't use it on just a sketch alone. The sketch won't produce a center of mass or center of gravity at all. You have to have a part. And that concludes our tutorial on how to use the center of gravity feature within Solidworks. This is tutorial number 147, and it covers how to optimize your sketches using the center of gravity feature within Solidworks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. So now in this tutorial, what I'm going to do is I'm going to show you how to optimize your sketches to create the center of gravity, and just like the last tutorial, we're going to be using that center of gravity feature to find the center of gravity of your sketch and then move it around to optimize it. So to start off, let's create a sketch. So let's click Sketch, click Rectangle, and click the front plane. Now when I'm making the center of gravity and how to manipulate the center of gravity, always have the origin contained somewhere in your sketch, because we're going to be using this this origin to move around the sketch after and find that center of gravity for the whole part and the whole sketch. So to start off, just sketch this out, sketch a rectangle out, and just make sure that the origin is inside of it. Now with the smart dimension, let's make this 50 by 50. And you can already see that the origin isn't in the center of gravity, so it would be at 0.2525. Now this is just an easy one, so I'm going to just kind of show you the logic behind how we're doing this, and then I'm going to show you a harder sketch to do. This one's kind of rhetorical. We already know where the center of gravity is. I'm just going to show you the steps, and then we're going to do a harder one after this. So create your sketch, make sure the origin's inside of it, click OK. Now click Features and click Extrude. And what we're going to do is we're going to do a mid-plane extrude. What this is going to do for us is it's going to eliminate one of the coordinates. So right now we're sketching on an X and Y, and the extrude's going to come out of the Z. Now if we do a mid-plane, it's going to do, right now, it's a 10 millimeter extrude, and it's going to do 5 on one side, 5 on the other. So when we go to do the center of mass, center of gravity, we're going to get a value of 0 for our Z. And that's what we want. We want to have an X, Y, and Z of 0, 0, 0, so that we can find our center of mass and know exactly where it is. So click OK, and now click on Mass Properties, and we're going to get our center of mass. Now, what you're going to have to do is either memorize those numbers or just write them down. So our X value is negative 2.87, our Y value is negative 14.87, and our Z value is 0, just like I said, just that's how it should be. So if we look at the object where the purple coordinate system or axis is the center, and where the blue is where our origin, where we want it to be. So what we want to do is move this whole sketch just so that it's going to be on that origin there. So when it says to move it negative 2.87, when we actually go to move it, we're actually going to move it 2.87. So it's going to be a positive. And with the Y, it's instead of a negative 14.87, it's going to be a positive 14.87. So now let's go and let's move this sketch and try to get it so that everything's going to be X equals 0, Y equals 0, and Z equals 0. So get into the sketch, click Edit Sketch, and click Tools, click Sketch Tools, click Move. Now click each of the lines in the sketch and make sure that you have it selected to XY rather than from to, so that we're able to use those values that we wrote down and move the object. So we had a value of negative 2.87, so we're going to type in 2.87. And then we had a value of negative 14.87, but we're going to type in positive 14.87. And now if we look at it, we can see the blue where it was, the green where it is now, and it looks like that is our center. So click OK, click Accept, and now we have our part and it's moved. So let's look at the center of mass again, and we have a value of 0, 0, 0. So now we've optimized this part and we know that the origin and where all of our planes intersect is 0, 0, 0, and that's going to be our center of mass. Now, like I said, this one was an easy one to do, so I'm going to show you one that's a bit harder. It's not so rhetorical. We don't know where the center of mass is, so let's do that. Let's delete these, and let's create a new sketch. So let's click Sketch, click Line, and just draw out a unique shape that we will not know where the center of mass will be. And again, just make sure that you have the origin somewhere inside of it. When you're actually making it, it might actually come outside of it, but just to make sure that we know where everything's going, just keep it inside. It's a lot easier to do. Click OK, and let's extrude this out with the midplane again. Doesn't matter what value it is, just use the midplane so that the Z is going to equal 0. Click OK. And let's use the mass properties. And this time we have a value of 5.57 and negative 6.37. Now using these values, we're going to have to move around that sketch again. So let's get into the sketch, click Tools, click Sketch Tools, click Move, and click each of the lines. And then we're going to insert these values. So we had a value for x of 5.57, so we're going to add negative 5.57. And for y, we had 6.37, negative 6.37, and we're going to put in positive 6.37. And now you can see from the blue and the green where it was and where it is now. And now let's check the center of gravity. So click the mass properties, and now we have 0, 0, 0, and you can see that the x is negative 0. Now the precision of this is at 2 decimal places, so likely 3 decimal places on. There may be some numbers, but for the most part we have it scaled down, and we have it correct to 2 decimal places for the center of gravity. And you can see that the purple is on our origin there. So now we've successfully created our center of gravity for our sketch. If you go into the edit sketch, and it's right on the origin, and that's what we're looking for. So in this tutorial, we've been successful to create a sketch and then move it around, and where the origin is, that's where our center of gravity is. So by using that, we're able to know when we create a part where our center of gravity is, and to know where we can move it around. And that concludes our tutorial on how to use our sketches and the center of gravity. This is tutorial number 148, and it covers how to optimize part center of gravity within Solidworks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. Now, in this tutorial, I'm going to show you how to place the center of gravity or the center of mass of your part onto the origin here. So that at this origin and at this point is going to be the center of mass, center of gravity of your part. And we're going to do this because we have all of the planes, the major planes, so the front plane, top plane, and right plane run right through that point. And plus, it allows you to manipulate and just use your part and create it the best way possible and implement it, say, in an assembly. And it just gives you more flexibility and freedom to do more things with your part just so that you know where the center of gravity is and to have your center of gravity at that origin. Now to start off, what we're going to do is we're going to create a couple offset planes from the front plane. So click this front plane here, click Insert, click Reference Geometry, click Plane, and make it 100. Click OK. And then we're going to do the same with the other plane. Click Insert, click Reference Geometry, click Plane, do 100, but reverse the direction. Click OK. So what we're going to do is we're going to create a sketch on this plane. We're going to center those sketches on the X and Y. We're going to extrude between the two sketches, and then we're going to change the Z direction, so the distance of both of these planes, to create the center of gravity and make the center point right on the origin. So to start off though, we have a 200 millimeter distance between the two here. So if you wanted your part to be 200 millimeters long, make sure that in between here is 200, because after, say we have to move this 5 millimeters one way, this plane's going to be 105 and this plane's going to be 95. Just so you know that beforehand, make sure that the distance between the two planes is exactly what you want. So first off, let's sketch on this plane. So what we're going to do first, is we're going to create a two triangle sketches. One's going to be a scalene, one's going to be an isosceles. So first let's draw a scalene. So let's draw it out. And a scalene has 3 unique lengths. So this sketch here, you can see 3 unique lengths for each side. Click OK. Click Feature Parameters, click Extrude, and do a midplane. Now, when we do a midplane this time, we're not going to get 0 in our Z. We're going to get 100 because it's offset 100. Click OK. And let's do the mass properties. You can see we got the 100, and then we're just going to be using the X and the Y. So our X is 3.87, and our Y is 6.53. Now they're both negative, so we're going to be putting in positive values. Now let's edit the sketch, and let's click Tools, click Sketch Tools, click Move, and let's highlight all the points so we have them, and you can see that we can move it around. Now in the X, let's put 3.87, and in the Y, let's put 6.53. And we can see the translation there between the green and the blue. Looks good. It's working for us. Click OK. And I don't think it went through, so we're going to have to do this again. So click, move, highlight those points, do 3.87 and 6.53. Now when we go to check, let's click OK, and let's check our mass properties. And we'll see that we have 0, 0, and 100. That's exactly what we want. So we're happy with this sketch now, so let's delete this extrude, and let's hide this sketch. Now let's go on to plane 2, and we'll do another triangle. Now, this time we're going to do a isosceles, so we're going to make 2 lines the same. So click any 2 lines and make them equal. Click OK. Now extrude it out, do midplane, just like the first one, do the mass properties, and we can see that we need a translation of 0.47 and negative 5.41. And the Z is at negative 100, and that's what it should be. So let's edit the sketch, and let's click Tools, Sketch Tools, click Move, highlight the points, click OK, and just go back into it. Sometimes I have a problem using this. For some reason, I have the points, I do the translation, I click OK, and it doesn't work. So sometimes when I highlight it, leave it, and come back, then it starts working better for me. So now let's type in 0.47 and negative 5.41. We can see the translation, looks good. Click OK, click OK, accept it, and let's do the mask properties. And again, we have 0, 0, negative 100, exactly what we want. Let's get out of it, and let's delete this extrude, and let's show the other sketch. So now what we've done is that our two sketches that we're going to loft between the two, they're already centered on the X and Y. So when we loft these two, our center of our center of gravity is going to be at 0x, 0y, and whatever z value is going to be. So now let's loft these two. Click loft, click each sketch. You're going to see the loft go through. Click OK. And now let's do the mask property. And you can see that we have 0, x equals 0, y equals 0. That's exactly what we thought we were going to get because we've already done the x and the y. Now, our z value is 12.55. And what we're going to have to do is we're going to have to shift each of these planes 12.55 millimeters. So what we're going to have to do is the plane 2 is going to have to increase, and the plane 1 is going to have to decrease. So let's do this. Let's click plane 1, click edit feature. And what we're going to have to do is we're going to have 100 and take away the 12.55. So what we're going to have is 87.45. So let's do that. 87.45. Click OK. And for plane 2, we're going to have to add. So we're going to have 112.55. Click OK. So now we've moved the whole planes over. Check the mask property, and we have 0, 0, and 0. So now we have the purple center of gravity is right on our origin. So our whole part, the center of gravity is exactly on the origin. And that's what we've set out to do. So now we're able to optimize using this part, as we know where the center of gravity is. The center of gravity runs through all the major planes, and we're able to manipulate and do what we want with this part now, knowing the center of gravity, and we're able to implement it even better in assemblies if we have to. And that concludes our tutorial on how to use the center of gravity tool within Solidworks. This is tutorial number 149, and it covers calculations and equations within Solidworks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. So in this tutorial, I'm going to show you how to use calculations and equations in SolidWorks to dimension parts and sketches. So to start off, let's just make a sketch. So let's click Sketch, click a rectangle, click Front Plane, and just draw one out. Now, when we make a smart dimension, we're actually able to make an equation in this box. So say that we have certain parameters that we are looking at, and say we want this length to be 20 divided by 2.5. Rather than doing everything on the side, we're able to just actually throw that in. So we can put in 20 divided by 2.5, and it automatically does it, and it's 8. Now we can go back in. It doesn't show the equation, but it just shows the answer. Now we can do more things, so we can have, say, 20 times, and we can even have brackets, times 3 divided by 1.5. We have 40. So you're able to, instead of going on the side, doing some calculations with a calculator, you're able to just use everything in here just like a calculator. So you're even able to put in things such as sine functions and cos functions in here. So you can put sine bracket 45 times 10, and it'll give you the answer. Now, you're able to do equations like that, or you can actually go in and use a calculator that they have. So if you click this button here and say Add Equation, it brings you to this box that we've worked on before with all the equations. So in here, as before I showed you, I kind of made equations and I made them equal something. So I was making equations just so you can kind of keep it on the side and just show what's going on. This time you're able just to input something. So this sketch is driven to this equation. So we can put, say, 12 times cos 60. Click OK, and it's driven. And the E there is the equation, and it tells you that it's linked to an equation. So you're able to either manually put in equations in here, or if you pull this down and click add equation, you're able to use kind of like a little calculator setup that they have here for you. So by doing these steps, you're able to increase productivity, as you don't have to go on the side, write down, use a calculator, and then put in your values. You're able just to do it through here. And also doing it through here is a lot more precise. If I was to calculate this on the side, I'd call it 8.51. I wouldn't do all these extra numbers. Now if you do it in here, it's going to automatically give you those extra numbers. So it saves you time and it keeps everything a lot more precise and a lot more tidy. And that concludes our tutorial on how to use the calculations and equations within SolidWorks. This is tutorial number 150, and it covers how to use the sweep cut feature within SolidWorks. Now to start off, let's open up a new part. Let's click File, click New, click Part, click OK. So in this tutorial, I'm going to show you how to use the sweep cut feature. So to start off, what we need is an object that we want to create a sweep cut through. So let's click Rectangle, let's click the front plane, and just make a long rectangle to cut along. Click OK, click Extrude, and let's make this 200 millimeters. Click OK. And now we have our little rectangle that we're going to cut a path through. So to do the sweep cut, what you need is a profile, so the shape that you're going to be cutting, and then you need a line that it's going to follow, so a path. So to start off, we're going to do an easy one. So we're going to just do a circle, and we're going to cut it on an angle. So first, let's click this face, click Sketch, click Circle, and we're going to make our profile. So just pull it out, click OK, click Accept, and now let's click the top plane, click Line, and now we're making the path for it to follow. So click the center point of the circle, and click any point along here. Click OK. So now we have our two sketches for it to do. Now make sure that you've created this in two sketches, because it's going to prompt you to select two different sketches to create this, this feature. So now for the feature, click Insert, click Cut, click Sweep, and the first one's going to be the profile, so click the profile, and the second one's going to be the path. So then click the line for the path, and you're going to see a preview. You like it, click OK, and now you've cut that profile through that path. Now you're able to go in and we can adjust either parameter. So first let's change the circle. So let's click Edit Sketch, and as it's already positioned on this line here, we can either bring it across if we wanted to, or we can make it larger or smaller. So let's make this a little smaller. Click OK, and then you can see the results at the end there. So now we have a smaller circle cutting through. And we can also do this with the path. So let's click Edit Sketch, and let's just totally delete this line, and let's use the spline. So let's click Spline, start it at the center point there, and just make a little path for it to follow, and just make sure that it ends on that line. Click OK, and now that circle has cut a line through there following that path. So it's cut the circle profile following the line through our block that we made. So now let's delete this cut sweep, and let's delete the sketches, and let's create one with a rectangle. So let's click this face here, click Rectangle, and just create a rectangle like that. Click OK. And for the path, click the line, click the top plane, and click a point along this line here, and bring it across to the other line. Click OK. And now let's make our swept cut. So click Insert, Cut, Sweep, and we already have the path that it's going to follow selected. Now click the profile, so click the rectangle, we like it, click OK, and now it's cut through. So we can do this with a circle, we can do it with a square, we can do it with any kind of profile that we want. and then you're able to change the line and whatnot. So this concludes our tutorial on how to use the Sweep Cut feature within SolidWorks. This is tutorial number 151, and it covers basic Loft Cut feature within SolidWorks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. Now in this tutorial I'm going to cover how to use the Loft Cut feature, and it's pretty much the same as the Extrude Loft feature. Just instead of creating a loft, you're going to be taking a loft away from a solid. So to start off, what we're going to do is, in this tutorial I'm going to show you a basic one, and what we're going to do is we're going to create a cylinder, and we're going to use the extrude, the cut loft, to cut a loft out of the cylinder. So let's click circle, click the front plane, and let's make a circle and make the diameter 200. And let's extrude it out 500 mils. Click OK. Now to do the extrude cut loft here, like I'm doing, what we're going to be doing is you need two profiles, so two different sketches to create the extrude cut loft out of. So let's click this face here, and let's sketch a circle on it, and we'll do it from the center point here. And let's make this circle have a radius of 150. And then let's do the same. Click OK, finish that sketch, and click this face here. And we'll do the same, and we'll make this with a diameter of 50. Click OK. So now we have our two profiles. So what we're going to do now is, with these two profiles, we're going to loft cut them out of this solid. So let's click Insert, click Cut, click Loft, and select both profiles, and you'll see a preview of the cut. Looks good, we like it, so click OK. And now we cut out the loft between these two profiles. Now we're able to change the two profiles, and it'll consequently change the cut loft that we just made. So if we changed this sketch, click Edit Sketch, and say we change the diameter to 150, like the other side, it's going to look like it went straight through. Click OK. And now it just looks like a normal cut all the way through. And if we changed this sketch here from 150 to 100, click OK, you're going to see the loft cut and just how it goes. So pretty much what you're doing is, from one profile to another, it's going to meet, and then it's going to cut out that profile. Now let's delete this cut here, and delete the two sketches. And just to show you, it doesn't have to be circles, it can be anything else. So let's do two squares. So click this side here, just draw a skinny square there, click OK, go on the other side, and just draw a normal square here. Click OK. Doesn't have to be precise with the dimensions, just make the two different kind of sizes. Click Insert, click Cut, click Loft, and click the two profiles. And you're going to see a preview of the two being cut. You like it, looks good, click OK. And it's going to cut the profiles out. Now, when you're doing two different profiles, the one thing that I have to stress that you must do is that with the two squares, there's 4 points on both of them. Whenever you're doing a loft between two, the easiest way so that you don't run into trouble is by using the same amount of points on each side. So if I had 4 points, like a square on this side, and say I had 6 points like a hexagon on this side, it's going to be a lot harder to create that loft, and it might not even be able to do it too. So the best way is just make sure that you have the same number of points on each side using each profiles. So you're able to use circles, you can use polygons, it's all up to you, but that's the basic fundamentals of doing a loft cut. So create two profiles and just join them together, and it lofts the two. And that concludes our tutorial on how to use the basic loft cut feature within SolidWorks. This is tutorial number 152, and it covers multiple loft cuts within SolidWorks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. Now, the last tutorial, what we covered was basic loft cut, and we used 2 profiles to make a cut. In this tutorial, I'm going to show you how to use multiple profiles to make one long loft cut. So to start off, let's sketch out a rectangle. So let's click Sketch, click Rectangle, click the front plane, and let's just sketch out a rectangle. Doesn't have to be precise, and let's click Extrude, and extrude it out 250 millimeters. Click OK. Now what we're going to do is I'm going to create 5 different profiles. So we're going to do one on this face, one on this face, and we're going to make 3 planes in the middle and create profiles on them. So to start off, we're going to have to make the 3 planes going through there. So let's click this face here, click Insert, click Reference Geometry, click Plane, and you'll see the yellow, and just reverse it so that it's going onto the object. And let's just make this one 50. Click OK. We'll go from the other face here, click Insert, click Reference Geometry, click Plane, reverse the direction, make sure it's going in, 50 millimeters away again, click OK. Now click either one of the new planes that we just made. So click one of them, click Insert, click Reference Geometry, click Plane, and reverse it, make it 75, and make it in the middle there. Click OK. So now we have 5 planes that we're going to sketch on. So the first one I'm going to show you is how to use a circle, and the last one I'm going to show you is how to use a polygon. So the first one for the circle, let's start sketching 5 different circles. So click on this face here, click Sketch, click a circle, and just draw a circle on there. And let's dimension this circle. Let's make this first circle, let's make it 25. Click OK. Now, click Accept for the sketch. And every profile you have to make a separate sketch. So now let's do this plane here. Click Circle. And let's look at it from the front view. And the circles don't all have to line up. For this one here, I'm going to just show you them all lined up. So every single one's going to have the same starting point. So let's smart dimension this. And let's make it 10 mils. Click OK. Go to the next plane, click Circle, and I'm going to look at the front view again. We're going to make this one 15. Click OK. Go to the next plane, click Circle, look at the front view. We'll make this one just 5 mils. Click OK, and now the last face, click it, click the front view, click Circle, and we'll make this one 50. Click OK. So now, if we look, we have 5 different profiles. They're all circles in a line, and we're going to use the Loft Cut feature to cut a loft using all these profiles. So let's click Insert, click Cut, click Loft, and let's select each of the profiles. So do them in order as it would be cut. And you'll see a profile of your cut and what it's going to look like. Now, once you can see that everything's in order and it looks good, click OK. And now if we look through, you can see the cut. Now, let's get a section view of this. So let's click Section View. And let's click the top plane, and let's see when we lift it up. If we look at the top here, you can see the profiles and how they all move together there. Now, this case, we made them all in one line. Now I'm going to delete this, and I'll show you another case that they're all shifted from one to another. Let's click OK. And let's delete this loft. And let's delete sketch 3, 4, and 5. Click OK. Now, on the middle plane, let's click on it and click circle. Look at it from the front. Now we're just going to make a circle that's just off to the side a little bit. We'll put it right there. And let's dimension this to be 15. Click OK. And now let's do that loft again. So let's click Tools, Insert, Cut, Loft, and click the 3 profiles. And you'll see that we can go on a little angle on the side like that. Click OK. And now we've made our cut. Now, let's open this up, and let's delete this loft again. And now each of these sketches, let's go in, and let's substitute it with a polygon. So, let's go into Sketch 2, click Edit Sketch. Look at it from the front, and let's delete this. And let's click Tools, Sketch Entities, and let's click Polygon. And let's make a 5-sided polygon. And just draw in a 5-sided polygon. Click OK. Now let's go to Sketch 6, click Edit Sketch, and let's delete it. And now let's make another 5-sided polygon. Click Tools, Sketch Entities, click Polygon. Make sure it's 5-sided. Make it in the center of this one. Make this one larger. And the last sketch, let's click Edit Sketch. And delete it. And we'll make another 5-sided polygon. Click Tools, Sketch Entities, Polygon. Make sure it's at 5. And like I said in the other tutorials, make sure that these polygons that you're using, make sure that they're all the same number of edges and points, just so that they can all line up nice. Click OK. And now let's do the extrude loft again, the extrude cut loft. So click Insert, Cut, click Loft. Now let's click each profile. And you can see how each of the profiles work together and create that loft. Click OK. And now you can see that we made that cut all the way through that part. So you can see that we can cut all of them in a straight line. We can go off to the side a little bit. Or we can also use things other than circles or squares. We can use other polygons. So you can use any multiple number of sketches, and as long as you match them up going all the way along, they're going to create a nice loft cut for you. And that concludes our tutorial on how to use multiple loft cuts within Solidworks. This is tutorial number 153, and it covers how to do advanced loft cuts within Solidworks. Now to start off, open up tutorial part number 153, which I've included on the DVD. Now, what we're going to be doing in this tutorial is much like the first two. We're going to be creating profiles to do a loft cut, but the difference in this one is we're also going to add a path for the profiles to follow, and that's going to be kind of like the advanced feature that we're going to include in here. So to start off, what we're going to do is we're going to make 2 profiles, and then we're going to connect them with one path. So let's click this face here, click rectangle, and let's look at it from the front, and just create a square. Doesn't matter about the shape or the dimensions. Click OK. Now let's click the other face here, and let's click rectangle, and let's look at it from the front and make the square exactly the same as the first one you made. Click OK. So now we have our 2 profiles. So what we're going to do is we're going to attach them. So let's click Line, click this point here, and just keep going back and forth, just making like a little pattern to follow, and end it at that point there. Click OK. So now you have the path that it's going to follow. So you have the 2 profiles and the path. So now let's click Insert, Cut, Loft. So let's click the 2 profiles, and you can see that they want to connect to each other to begin with. Now click the guide curve, click the curve, and you're going to see that they're going to follow the curve that we imposed on them. Now click OK, and you're going to see the cutout that it's going to give. Now by using this profile, we're able to manipulate exactly where it's going. So we can go back and let's edit the profile. So it's the fourth sketch here. Click Edit Sketch. And just by hand, just click on some and just move them around. Click OK. And you're going to see that it automatically adjusts what's going on with the two profiles within the cut. Now, let's delete this cut. Let's delete sketch 4. And let's create a couple more rectangles on these 3 planes here that we still have. So click each plane and let's make another rectangle. Let's look at it from the front. And let's make a couple different designs now. Let's make a skinny one here. Click on the middle one. Click rectangle. And let's look at it from the front. And let's make one that's a little bit more thin. And let's just drag it across a bit. Click OK. And on the last one, let's click rectangle, look at it from the front, and let's do another thin one. Click OK. Now let's add our little profiles. So let's click line. Actually, this time let's click spline. And we'll click the top face there. And now let's connect some of these points and just add a bit of curves, a little bit of a curve to each of these. Sorry, I just messed up on there. So just make sure that you're connecting the same corner and that you're getting the red dot. Click OK. So now you have your path and you have all your profiles. So let's try this again. Let's go to Insert, click Cut, click Loft, and let's click all the profiles. And we have the path. Let's click OK. And now we've created our cutout there. Now if we go back into it to edit it, if you notice when I was playing around with it there, I only had the first 2 showing. You might have to go and take out the profile and then put it back in sometimes just to get the right curve, just because sometimes the feature, like this function here, is going to select things in the wrong order and it might screw up what it's going to look like at the end. So something like the profile you might have, or sorry, the path you might have to delete and then kind of put back in. Alright. And then again, you're able to go back, you're able to change all the different profiles, all the different paths, and you're able to change your loft cut. So for an advanced loft cut, what I've kind of showed you is doing what we did in the last one with like the multiple lofts, having a bunch of different sections. But this time we've just introduced a path for them to follow. So rather than the natural path that they would have followed, you're kind of imposing a path on them and they'll follow that path. And that concludes our tutorial on advanced loft cuts within SolidWorks. This is tutorial number 154, and it covers the simple hole feature within SolidWorks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. Now, what we're going to be covering is how to use the simple hole feature in SolidWorks, and what that is it's pretty much the same as the hole wizard that we've used in a previous tutorial, but the difference is the hole wizard, you do more complicated holes with chamfers and counterbores and countersunk. With the simple hole, it's just doing a basic hole, straight in, straight out, no chamfers, nothing else. So what we're going to do first is create a block that we're going to be cutting everything into. So let's click Sketch, click rectangle, click the front plane, and just draw out a square. And let's extrude it out, and just keep extruding it out until it looks like a square. Click OK, and now we've got a little block that we're going to be editing. So first off, the Simple Hole tool is found under Insert, Features, Hole, Simple, and all you have to do is, with the block, choose the side you want to cut a hole through. So we want this side, click here, and where you click is where the hole is going to be placed. So right now we have a 10 mil diameter hole, and it's going all the way through. Now say we like it, click OK, and you've got your hole. Now the advantage of using this rather than going through and making a sketch is that you have to go make the sketch, then you have to cut it out. This just kind of takes out one step, just lets you go in, cut your hole, select it, and you're good to go. Now let's say that you wanted to change the position of that hole. Say you wanted it in the corner and you want it 20 from here, 20 from here. To do that, go into the hole that we just created, click the sketch, right click, and click Edit Sketch, and now you're able to go in and edit the positioning of the hole. So click Smart Dimension, click this point, click this line, let's make it 20, and let's make it 20 from here. Click OK, and now we've moved our hole over. And again, say we want to change the size of the hole, say we want to make it bigger, just right click and edit the sketch, and let's make the diameter, let's make it 20, click OK, and we've made it 20. Now let's go and make another hole, so let's click Insert, and Simple Hole. Let's click this face here, and this hole, it works exactly the same as the cut feature when you're cutting through. So if you do a through wall, it's going to go all the way through. If you do a blind, you can make it go just 20 mils in, and you're also able to change the diameter from here. Now say you have your hole, and say you just want to move it around anyways. You can just actually grab it, and now you have the hole, and you're able to put it anywhere you want. So let's throw it up here on top, and now the hole's up there. Grab it again, throw it at the bottom, the hole is going to be there. So you're able to manipulate just by grabbing it too, rather than actually setting in fixed dimensions. Now let's click OK, and we put another hole down there. So this tool is really quick and easy to use compared to clicking a face, creating the sketch, then cutting it out. You're able just to do it all pretty much in one step. And that concludes our tutorial on how to use the Simple Hole feature within Solidworks. This is tutorial number 155, and it covers how to use the Scale Part feature within Solidworks. Now to start off, let's open up a part on the DVD. So let's click File, and let's open up one of the hinges that I've included on the DVD. You can find this in the samples. So let's open it up. Now what we're going to be doing in this tutorial is I'm going to show you how to scale a part. And the reason behind scaling a part is if you have a part such as this, it's intricate and you don't want to duplicate it again, but you need it, say, twice the size of what you have now. Instead of going back, editing either the dimensions through your list here, the sketches and whatnot, or by just starting out from scratch again and doing it again, you're able just to click the whole part and just scale it. Now, one of the things that I had to do in this part was I actually had to scale it. So I had drawings, and they wanted me to scale it back because they were just going to be making a prototype for it, and they didn't want it to be as large as what it was going to be on the actual application. So I think this one's actually scaled back. I think it's about 5/8 to what it should be. So I actually made it normally, and then I changed it using this scale to scale everything back. So I'm going to show you how to do that. So what we're going to do is click Insert, click Feature, click Scale, and then there's nothing you can really do wrong. You just have to select the part, and it's going to select the whole thing. You don't have to click any faces or any specific features, so just click it. And for this one, let's do 2 times. So whatever you put here, that's how big it's going to be. If you have 1, it's going to stay the same. 2, it's going to be twice as big. And you're able to scale it from a few points. You're able to do it from the centroid of the part out, or from the origin. So it's going to be, say the origin's here, it's going to scale it out that way. From the centroid, it's going to scale it out kind of like in a circle. So the best bet, I would say all the time, is using the centroid, or you can do a coordinate system if you have it in there. But do a centroid, it's the easiest one to do, and it makes the most sense because it's going to go out from the center of the part. So we want it 2 times as big. Let's click OK. And now the whole part's twice as big. Now, if we measure from this face to this face here, it's 1.56 inches. Now, let's scale it again. So let's click Insert, click Feature, click Scale, and this time, let's make it 5/8. Click OK, and it's going to scale it back down. Now, if we measure these faces again, we're going to see that we have a difference. Before it was 1.56, now it's 0.97. So obviously everything's scaled down, and everything gets scaled together, so it keeps it nice and tight. So rather than, the outside of the part just getting bigger and the insides and the holes not going, the whole part gets scaled all together, so it keeps it a nice clean look. Every time I scale this, and if I zoom in, it's always going to look the same. So let's scale this again, and let's scale it 10 times. Click OK, and it still looks the same. Nothing's really altered or disfigured or anything. It works very, very well. So using this, it's very easy. It saves you a lot of time, and it gives you a great result when you're trying to, if you already have a bunch of components, like say you had, this is like a standard hinge or bracket that you got going on. If you have this as a standard, you can just make one and then scale every single one off of it, so you only have to do the part once. And this concludes our tutorial on how to use the scale part feature within SolidWorks. This is tutorial number 156, and it covers how to use the dome feature within SolidWorks. Now to start off, let's open up the new part file. Let's click File, click New, click Part, click OK. So in this tutorial, we're going to be covering how to use the dome feature, and what that does is when you have a solid, you're able to create a dome coming off of a face, and using that face and the points on that face, it's going to create the dome and shape it. So to start off, let's just draw out a square. So let's click Sketch, click Rectangle, click Front Plane. Just draw out a square just by looking at it. Doesn't have to be exact. Click OK, and extrude it out, and let's just extrude out 50. Click OK. And what we're going to do is we're going to make a dome, and we can find the tool on Insert, Features, Dome. So let's click Dome, and all you have to do is just click any face, and it's going to create a dome. So let's click this face here, and we can see the dome that's popping up. So what the dome's doing is we've specified it's going to be a 10 mil height, so the center of the face is going to be up 10 mils, and then it's going to taper off to the points and the edges. So if we click OK, we can see that we've created a little dome there. So the dome's pretty much, you can't really make it yourself if you were trying to. It's a feature that you need to use specifically. It's not like you can replicate it anywhere else. Now, you're able to make a dome going out, and you're also able to make one that goes in and actually cuts into the material. So let's do one on this face here. Let's click Insert, click Feature, click Dome, and you're able to change the direction right here. Now, or you're able to choose the direction by clicking here and clicking a line. So we can click this line, and it's going to follow the direction. Now let's get rid of this edge. So right now, it's creating a dome on the top, and if we flip the direction, it's going to make a dome inside. So let's click OK. And we can see that we've got a dome on the outside there, and we got a dome on the inside there. Now let's make another dome here, and let's make it bigger. So let's click Insert, click Feature, click Dome, and instead of 10, Let's just keep going up and up. And you can see that we have 70 millimeters here. So what it's doing is at the point on the top here is going to be 70, and then it's going to taper down to those points. Click OK, and we've made a 70 mil dome there. Now let's go on the other side, and let's do a 70 mil cutting in. So let's click Insert, Feature, Dome, and instead of going out like it is right now, let's make it go in. So flip the direction, and you can see how it's being cut. Click OK. And I guess we're going to have some errors because the cut's too big. So let's bring this down to, let's do 20. Click OK. Still a rebuild, eh? So let's bring it down to 10. Click OK. So you're going to have to play around with, I guess, the sizes and how much you're going to cut in so it doesn't, I guess, destroy everything else going on there. So we got a 10 mil dome again there. But you're able to play around with it and you're able to cut in something such as this going in. So you're able to do it to surfaces such as these ones, but you're also able to do it to more intricate surfaces. So the hinge that we opened up in the last tutorial, let's open it up too. So let's click File and open up the hinge. It's on the DVD. It's read-only, don't worry about that. And you're also able to do a dome on a surface such as this. So let's click this face here, click Insert, click Feature, click Dome, click OK, and you can see that we've created a dome on the top of this surface. Now these domes are going to be a little bit different because when you have cutouts and whatnot, it's not going to go around, it's not going to go through the cutout, so it's going to take it into consideration with like the pulling points. Now let's do one on this face here. Click Insert, click Feature, click Dome, and again you can see that it's not going to go through any of the circles or the cutouts, but it's just going to stay in the middle there. And if we keep increasing it, it's just taking a while because it has to figure out everything, and it's a little too much for my computer right now. But you can see that the dome's going to come up, and it's taking into consideration all these cutouts, and it's not going to go through any. So click OK. And we got another dome coming up around there. So you're able to do it to either just a flat plain surface or one that has a bunch of features on it like this one. And that concludes our tutorial on how to use the dome feature within SolidWorks. This is tutorial number 157, and it covers how to use the Freeform feature within SolidWorks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. So what we're going to be doing is covering the Freeform feature, and what the Freeform feature does is when you have a surface, you're able to click on a face and manipulate the points on that face, and it's going to do that to the part. So you're able to rise points and pull them back into the face, so you're able to bring parts up, bring parts down, and it's a really, really fun tool. It lets you be creative and just manipulate and play around with it as much as you want. So to start off, let's just make a cube. So let's click Sketch, click Rectangle, click the front face, and that guy's a little bit too small, so let me pull him out. And we're just going to have a square. And just extrude it out. Doesn't have to be perfect. So what we're going to be doing is with this cube, we're going to play with the freeform, and we're going to be selecting a face and manipulating the points on that face, and it's not going to be a flat surface anymore. It's going to have peaks and valleys and whatever it is that we want to put in. So let's click Tools, or sorry, Insert, click Feature, click Freeform. So now we have this face is selected, and you're able to do a couple selections down here. The mesh density, the more you increase it, the more grid lines you're going to see. Doesn't really matter, I don't think. Just leave it at whatever setting it was. If you click here, you can see zebra stripes, and the zebra stripes are going to allow you to see when you do put in curves and play around with it. It's going to be able to, you're going to be able to see more what's going on, how the curves are reacting and whatnot. So let's leave that on. So to start off, what we're going to have to do is we're going to add a curve. So click Add Curves, and you're just going to make a line. Now let's say we want to make a line here, so let's just put it right here. And if we click Add Curves again, and if we click our line, you're going to see that we have 2 arrows. Now these arrows are going to be like our little anchoring points, so if we click and hold, we're able to move that around, and you're able to see the curve move with it. So when you click on it, you're going to get a triad, and that's what we have here. You're able to either just move it straight up and down, towards you, away, and this is just like your X and Y axis. So if you click the center, you can move it around anywhere. If you click the arrow, it limits you to that one axis. So you're able to play around with this guy here, and let's say you want to play around with this guy here. You just grab him and just drag him around. Click OK. And now you can see that we have some peaks and valleys. Now, if we go back into the Freeform and click Edit Feature, and let's turn on the zebra stripes again, just so we can see the curves. Let's add another line. So let's click Add Curve, and let's add one up here. Now let's click Add Curve again to deselect it, and let's click on the line, and let's play around with some of these points again. So let's bring this guy way up here, and let's just move this guy out there. And let's click OK. And you can see again that we're playing around with these surfaces, pulling them around, and just manipulating them however way we want. Now if we go back in again, if you've noticed on these lines, all that we've had so far is 2 anchoring points. Now we can add points to it. So let's click, we already have that line there. So let's click this line, and let's click Add Point. And if you put the cursor along the line, as you can see, it's going to have a red dot, and wherever you put it, that's going to be another anchoring point. And we'll put another one there. So now we have 4 anchoring points in total. Now let's click Add Points. So now we can select these guys, and we can manipulate them too. So now on this one line, we have 4 anchoring points. Click OK. And if we go back into the Freeform again, you're able to do it to the other line too. You can add as many as you want. It's all up to you. The more you have, the more control you have. So let's choose another face now. Let's choose this face here. Click Insert, and click Freeform. And let's add 3 lines here. Now, the one thing with Freeform is that to get good at it and to get the results you want, you just have to play around with it. The more you play around with it, the better you're going to be with it, and the more in control you're going to be with your part. So I'm going to click this guy here. I'm just going to pull that one in, pull this one out. Click this line here, pull that guy up, and I'll pull that guy down. And I'm going to click this line here, pull this guy down, and pull this guy up. Click OK. And you can see again some more peaks and valleys and just controlling the surface. So if you have an object or a surface or just something that you want to make, you don't really know how, you can't really see a way by just using basic tools such as these, as the loft, the extrude, and the sweep. If you make the basic shape and then start playing around with the freeform and just the points, you can call like the anchor points, the contact points, where it's actually going to make a difference. You can start pulling those points, playing around with them until you get a shape that you want. So the freeform shape lets you be creative, it lets you make a unique shape, and it gives you a lot of flexibility to play around with. So really, the more you play around with it, the better you'll get with it, and it just takes practice to kind of get the results that you would want with a freeform. And that concludes our tutorial on how to use the freeform feature within Solidworks. This is tutorial number 158, and it covers how to use the shape feature within Solidworks. Now, the last couple tutorials, we've covered how to use the freeform and how to use the dome feature, and you can see this one here is a dome, and this one here is a freeform on the top there. Now, the shape feature is kind of like the dome and the freeform, except that you get to manipulate it a lot more and get to do a lot more stuff to what you want it to do. With these, you're more limited to what they give you. So, like with the freeform, if you go and edit it, you have to use the lines that are on there and the points and stuff. So, with the shape feature, you're actually able to insert kind of like a sketch and make it come up to that sketch. So you're able to make sketches however it is that you want it to be, and you're not limited to just putting a line there and playing around with the points. So it's just another way to do pretty much the same thing, gives you a little bit more freedom again. So to start off, I'll just show you where the tool is. If you click Insert, click Features, click Shape, then you're able to use the shape feature. So what we're going to need is we're going to have to make a sketch that's offset from one of these faces. So to start off, either create just a cube or just any shape that you want to create your shape off of. So to start off, what we're going to do is I'm going to make sort of like a dome. Like this dome here, I'm going to make it on this side here. So let's click this face here, and let's insert a plane. So let's click Insert, click Reference Geometry, click Plane, and now we have a plane. Click OK. So now we're able to sketch on this plane, and then we're able to make the shape come out, and it's going to be representative of that plane and the sketch. So let's click Sketch, and let's click Circle, and we're already selected on this plane. So let's just draw a circle in the center here. Doesn't matter how big you make it, the bigger it is, smaller it is, it's just going to be, you're going to see the change from being a smaller circle, a bigger circle. It's going to be a correlation between it. So let's click OK, and now we have our sketch there for the circle. So now let's click Insert, click Feature, click Shape, and now it already has the constraint, so it's going to be this sketch here. So it already has the sketch that we just made as a constraint, and whatever the constraint is going to be the sketch that it's going to come out as. And then you're going to have to pick the face, so let's click this face here. And now we have our two parameters that we have to pick. You have to pick a face and a sketch that you've made. So let's click OK. And you can see that we've sort of made a dome like down there while using the circle. Now what's cool about this too is if we offset this plane some more, let's click Edit Feature, and let's say that we want to offset it to 50, click OK. Our shape follows the sketch that we just made, and it's going to keep moving around with it. So you're able to make a sketch, and you're able to make kind of like a form or a shape come out of the object, and it's going to be representative of that sketch that you've made. So as you can see, pulling the plane front and back, the shape is going to follow it from front to back. It's going to move around with it. Now let's edit this sketch again. Click Edit Sketch. And let's make this circle smaller. So I have the radius here. Let's just make it 5. Click OK. And now you're going to see that the whole shape is going to follow in correlation to how big the circle is, how big your sketch is. So now it's gotten smaller as our sketch and our circle has gotten smaller too. Now you're not limited just to doing a circle, so let's do another one here. So let's click this face. Let's insert another reference plane. So click Insert, click Reference Geometry, click Plane, and we'll keep it at 30 from that face. Click OK. And let's click Line, click the plane, and let's draw a line from one corner to the next. So it doesn't have to be exact, just draw a line such as that. Click OK. And now we have our sketch that we're going to use to create the shape. So let's do it again. Let's click Insert, click Feature, click Shape, and again, our constraint is already picked for our sketch. Now we just have to pick the face, so we'll pick this face here. Now you're able to pick a preview if you want to, so let's just preview it before we click OK. Click Preview, and it's just going to give you a little preview of what's going on there. Click OK. And we have the shape coming out. So you're not just limited to using a circle, you can use a line too. And you can see that it's coming out in the shape of the line, just coming up to it. Now again, if we change the reference plane. Let's say we bring it a little closer. So let's right click, click Edit Feature, and let's bring it to 10, click OK. And the shape and the feature, it's going to follow it again. So with this tool, if you make a sketch that's on a plane or another surface that's away from the face that you're going to be using, you're able to manipulate what kind of form or shape is going to come out of there, and it's going to look like your sketch. So in this case, we used a circle in the middle, and it comes up and it goes to that circle. In this case here, we use a diagonal line. It's going to come up like a diagonal line going across there. So compared to using a dome or freeform, you're able to just create a sketch. You're not limited to the control points or it being a dome. You're able to move it around, gives you some more control, and it's just another tool with these all. They're all pretty much the same, but it's just another way of going around and going about it. And this concludes our tutorial on how to use the shape feature within SolidWorks. This is tutorial number 159, and it covers how to use the Deform point feature within SolidWorks. Now to start off, let's open up tutorial part number 159, which is located on the DVD. Now what we're going to be doing in this tutorial is we're going to be using the Deform point feature, and we're going to be applying it to a cylinder and a cube. So to find the Deform point feature, what you have to do is click Insert, click Feature, click Deform, and on the side here you're going to have Point, Curve, and Surface Push. For this one we're going to be using the point. So let's click the point, and to start off let's do a deform on the cube. So what you have to do first is click a point that you want to deform. It can either be on an edge, on a surface, it can be anywhere. For this to start off, I'm just going to click the corner here, and you're going to see the arrow, and you're going to see the yellow, which is going to be like a preview of what the deform is going to look like. So we have a little arrowhead here, and you can see the deform coming out. Now if you click on it, you're able to toggle it in and out, so either it's going to cut into the part, or it's going to go outside of it and add material. Now on the side here, we have a couple more parameters that we can play with. So the first one here is the deform distance, so how far out it's going to go, and the other one's the deform area. So the more we click this, the more we increase it, the more it's going to go out. And with this guy, the more we make it, the wider, the bigger the area it's going to consume. So to start off, let's just do 10 by 10. Click OK, and you can see the deform that's come out of it. It's come out just around that point on the corner, and it's come out. Now let's do another one on this corner here, and let's deform it in. Let's click Insert, click Feature, click Deform, and let's click this point here, and let's flip it in. So either you can click on the arrowhead, or you can click on the reverse direction button here. It's up to you. And we'll just do 10 by 10 going in again. Click OK. And we've deformed in. And you can see that in this case we've taken a chunk out of the part, and in this case we've added to the part. Now let's play with those dimensions on it, and we'll click on a line instead of a point. So click Insert, click Feature, click Deform, and if you click on this line, wherever it is that you click, that's where your deform is going to be. So if I do it more to this side, my deform is going to be closer to that edge. And if I get rid of that point, if I do it more in the middle, the deform is going to be closer to the middle. So we can also play with these dimensions here, so let's start doing that. Let's pull it out a bit. So let's make it go out 30. And let's click OK. And you can see that the deforms come out 30, and it's still an area of just 10. Now let's go in and let's edit this one. So just to edit it, find the deform that you just made, right click, click Edit Feature, and you're able to edit your deform. So let's make the area 30. Click OK. And now we're going to be going out 30 plus the area all around it's going to be around 30. Now, we don't have to just do it to flat surfaces such as a square. We can also do it to something like a cylinder. We can do it on the side. So let's do that. So let's click Insert, click Feature, click Deform, and just click a point anywhere on the curved surfaces. So just click anywhere, and you can see the deform coming out of it. Now let's just make this go back to 10 and 10. And if you scroll down, you have some more options for the shape, so you can change stiffness. So right now we have a medium. If we click this one, it's a minimum. And if we zoom in, and if you look at it on the side, you can see that from this, which is a minimum, to a medium, it gets a little fatter, to the largest one, which is the maximum, and it's the fattest kind of deform that's going to come out of it. So you have more parameters again to play around with. So this is the normal one we do. Let's just do that. Let's click OK. It's on medium, and we have medium deform 10 by 10 coming out of the cylinder. So it doesn't matter if it's a point, a line, a face, or a curved face. You're able just to pick a point anywhere on it, and you're able to deform out of it. And again, if we click Insert, Feature, click Deform, and just click any point on the curved surface there. And again, we're able to play with the stiffness of it, which is just how it's going to look. So if we look at it on the side there, that's the minimum, that's medium, and that's max. So it's just how fat and how wide your deform is going to be when you pull it out. And we'll just accept this. And you can see that if you go a certain distance deforming it out, it's actually going to pull material out from the other side too. So let's actually do it on this face here. Let's delete this last one we just did. And we're going to pull one through this face. So click Insert, click Feature, click Deform. And you can see on the back that when it's at 10, there's nothing being pulled out. And as you keep going, more and more is going to be pulled through. So let's just see what this is going to look like. Click OK. And you can see that as we pulled that through, it's deformed through the back. And it's going to have a correlation between how much it's going to be pulled through the back and through the front. If you can see the deform that we pulled out and what's going to be pulled out of the back too, you can see that they kind of jive together, and that as you're pulling it out, it's kind of pulling out from the back too. So that concludes our tutorial on how to use the Point Deform feature within Solidworks. This is tutorial number 160, and it covers how to use the Deform Curve-to-Curve feature within Solidworks. Now to start off, let's open up the tutorial part number 160, which is located on the DVD. So in this tutorial, what we're going to have is a cube and a cylinder, and I'm going to show you how to use the Deform Curve-to-Curve feature. So to start off, let's open up the Deform feature tool. So let's click Insert, click Feature, click Deform, and again, you're able to choose from Point, Curve-to-Curve, Surface Push. So let's click Curve-to-Curve, and what this is going to do is you have to pick curves or lines on the object, and some are going to be kind of like holding it, and some are going to be the ones that are going to be deforming it. So to start off, what we're going to do is we're going to use the square or the cube. So first, what you have to select are the initial curves, and these are kind of like going to hold down your square. So to start off, let's just click this line here, and then in this box here are your target curves, and these are the ones that are going to be moving around your assembly or your square or whatever your object is. So let's click this line here, and then you're able to see a preview. And it'll show you in yellow what it's going to look like. Now if we click OK, then we're going to get our deform feature as such. Now if we go back into it, if you right click, click Edit Feature on the deform you just made, you're able to go back and you can change which lines you use. So this time, let's hold down this line, and let's choose this line to deform it. And this time we get another different kind. Now, when you put in which lines you're going to be deforming, you're also going to have these little arrows that you're able to toggle. So if you click on the arrow, it's going to move which direction the pull is coming from. So you have two sets of arrows that you're able to play with there. And if you scroll down and if you click curve direction, you're going to have another set of arrows. When I click curve direction, you're going to see right now I only have the green arrows, and when I click curve direction, then I have the blue arrows. And if I click surface tangent, then I'm going to have surface tangents too. Now let's just click none, and we'll just deal with the two right now. But having either the surface tangent, or if you have the curve direction, you're going to have another set of arrows that you're able just to toggle back and forth also. So just click none and just stick to the two. And again, let's click OK. Now sometimes if the curve is too much, or if it collapses on itself, it's not going to let you do it. So let's just delete one of these lines here, and it's going to pull it through. So for the deform, either for the deform curve to curve, you can either do it on a single object, such as this, just like on the square. In the first tutorial, we were doing just the point on just one object, but with curve to curve, you're also able to bring two objects together. So right now, I just kind of showed you how the single object works, and what I'm going to show you now is how to kind of bring together this cube and this cylinder. So let's delete all these lines here, and for the initial curves here, let's click these lines all around the square on the top, and then the target curve, have this box highlighted here, click the bottom line, or face if you want to call it, of the cylinder, and now you're going to see that the two surfaces are going to come and touch each other. They're going to kind of combine together. And the whole idea behind doing a deform is that regardless of what the sketch is and what the sketch is going to looks like initially, you're able to deform the curve to something you would not be able to do normally. If you were just trying to use sketches, it would either take you too long or something that you probably wouldn't be able to accomplish. So this lets you get out of the box, lets you bring an object in the right size, and then lets you deform it, and it doesn't have to rely on the sketch that you have before. So like the square, I have a square sketch from before. If you look at the yellow profile of what's going to be coming out of it, looks nothing like the square. It doesn't even fit in the same really size. It gets smaller, but you're still able to deform it. And again, you're able to toggle these arrows to get the shape that you want. And if you go down to the bottom, like in the other one, you're able to change the stiffness from a min, medium, or max. So right now, let's just put it to min, and you can see in the preview what it's going to look like. Pretty much this square and the cylinder are going to merge together. So let's see if it's going to go through. Let's click OK. And it's not, because it's going to be self-intersecting. So we're going to have to play around with these arrows and where it's going to toggle between. Now it looks like this will probably let us go, and it'll probably work. So let's try it again. Click OK. And again, it's not, so let's change this. Let's put it to max. Click OK. And now we got it to work. So when you're playing around with this, it's really touchy-feely. You just have to keep going until it doesn't really intersect itself. That's the only time you're really going to come into problems. So let's go back into this and edit it. So you can see that we had all four edges selected here, and we had the bottom edge selected here. We put it onto the max stiff, and you can see in the preview how the square is going up to the circle. Now let's just accept this. Now if we wanted to do this without using the deform feature, it would be very, very difficult, and we probably wouldn't get the same result merging the two together. So the deform curve to curve, it's used when you want to kind of bring two objects together, so you get kind of like a blend. So if you have whatever it is, like how we had the cube on this side and the cylinder on this side, you're kind of bringing the two objects together, kind of blending them and making them one. Now, like I was saying before about the sketch, if we look at the sketch of what the square was, and it's the green there, it's not even close to the deformed feature of the square after. So even though we have a sketch initially, we're able to really play around with the object and really pull it out from its original shape and structure without losing the shape, the size, and really like the dimension that we started out with. So it lets you manipulate it, but you're not going to crash. The program's going to let you create this object regardless if you're coming out of this box. So it just gives you some more freedom to play around with. And this concludes our tutorial on how to use the Deform curve-to-curve feature within SolidWorks. This is tutorial number 161, and it covers multiple Deform curve-to-curves within SolidWorks. To start off, open up two tutorial parts located on the DVD. They are tutorial part number 161A and 161B. Now if you look at the two, they are identical, and what I'm going to show you is that we're able to create a different object by blending three different objects together using the Deform curve-to-curve, but also the sequence in which you put these together will result in a different final product. So I'm going to show you how to mesh three of these together, and then I'm going to show the difference between doing one style. So on 161A, we're going to do one style, and then on 161B, we're going to do another style. So it's just a different order of how we're going through it, and we're going to get a different result. So to start off, let's go to 161A, and let's open up the Deform feature. So click Insert, Features, click Deform. So let's click Curve to Curve, and we'll start off by clicking the circle, and then click the target curves, and we'll do the hexagon here. So let's start clicking all the edges all the way around. Looks good. We like it. Click OK. And now we have our first deform. Now, let's do one more, and let's bring this square into this deform that we just made. So let's click Insert, click Features, click Deform, and let's click the four sides on the square. Now let's click these edges here, and it looks like what we want. Click OK. And if we click on Extrude 5 and if we hide it, now we've got a deform using three shapes and kind of bringing them together. So this certain shape that we've ended up with, we wouldn't be able to do it just with one deform. So we've kind of brought three different objects together and kind of molded them together. And this is a really good tool if you have multiple bodies that you want to bring together. You're able to do this. So you're not just relying on two bodies to make one certain object at the end. You can bring as many as you want in and slowly build them up and deform them all together into one. Now let's go to 161B, and we'll do it in a different sequence and we'll get a different result. So click Window and flip over to 161B. So let's start, and let's click Insert, click Feature, click Deform. Now let's start off by clicking these four sides on the square. And then we'll click the circle, click OK. And we might just have to flip this around. Let's get rid of lines and try it again. Sometimes it's just the order that you pick that it doesn't like, so you just have to keep trying until everything looks good. And this one looks good, so let's click OK. And now we're going to do the same with the hexagon going to the circle. So click Insert, click Features, click Freeform, or sorry, click Deform, and we'll click all the sides of the hexagon, and then we'll click the circle. And it looks like this one's good too, so let's click OK. And now we've got 2 deforms on each side. Now let's click Extrude 2, and let's hide the cylinder in the middle. And now let's bring these 2 deforms together. So let's click Insert, click Feature, click Deform, and let's click the deform from the square first. And now we'll click the deform from the hexagon. And it looks like it's going to go through, so let's see, let's click OK. No, so let's try flipping it. And that's not right, so let's click Control Z and just back it up. Now let's try this again. And like I showed before, sometimes it's just the order that you do it in, and you just might have to go back and just try it all over again. And let's see if it'll take it this time. Okay, let's delete all these edges here in this box from the hexagon. And let's try them again one more time. And there we go. So sometimes you just have to change the order, and you also have to change, if we go into the feature, the shape options. So just by playing around with those, then you might get it to work. So now we're left with this as our deform. So we've deformed off of the square and the hexagon into the cylinder, and from those 2 deforms we brought them together. So now we've got a different shape than what we got in 1618. So if we flip between the 2 by pressing Control Tab, you can see the 2 different results that we got from the exact same set of objects. So depending on the sequence and the order that you're doing your deforms, and which edges and what variables we put into it, we're going to get different results all the time. So in this tutorial, what I'm trying to show you is that if you have multiple bodies, you're able to slowly bring them together to make a deform that you want. And depending on which order that you're deforming in, you're going to get a different result every time. So this tool, again, it's very nice. You're able to really play around with it, and you're able to manipulate it, and slowly you're able to get it to do what you want it to do. So it's a very creative tool. It's not very math and I guess very engineering, too much engineering behind it. It's more of an artsy and more of a feel to get the look and the style that you're looking for. So that concludes our tutorial on the multiple deform curve-to-curve feature within Solidworks. This is tutorial number 162, and it covers how to use the surface push deform feature within Solidworks. To start off, let's open up tutorial part number 162, which is located on the DVD. So in this tutorial, we're going to be covering the surface push deform feature. So what that is that we're able to deform surfaces that we select using an object from the surface push deform feature. So for instance, say that we want from this object here, this profile here, say we want to change it so that it curves up and down like that, and also for the bottom to follow. This is a tool that we would use to deform that specific area using either a sphere, rectangle, any object that we're implying into it. So to start off, let's open up the surface push deform feature. So click Insert, click Features, click Deform, and make sure that you click the surface push. Now to do a surface push, you're going to have a triad located here. So you can either use the triad or you can use the tool body position. Using the tool body position is a lot more precise, but in this tutorial we're just going to be using the triad just so you can get a feel of when you move it around what it's doing to the object. So let's do that profile change that I was talking about. So let's try to get this lip to curve up and down like that. So to do that, the first step is to choose your deform region. So the surfaces that you want to move. Whichever ones you select are going to be able to move and deform. The ones that you don't select aren't going to change at all. So you have to be careful which ones you're going to choose. So in this case, we're going to choose this face here, and this face here. So by choosing these three faces, we're going to be able to get that profile we're talking about, but none of the other faces on the object are going to change, and that's what we want. So now you have to choose the body that you're deforming, so it's just the overall body. Doesn't matter where you select, just click the body. And then you're able to choose the push direction, so let's click this. And say we want it up and down, so you have to choose a line that's going in that same direction. So let's click this line here. And you can see you get a little up and down arrow there, so you can flip it which way you want it to go. So we want it going up. And then you're able to choose the tool body. So this is the body that you're using to push into your original object. So you can choose from an ellipse, an ellipsoid, a polygon, a rectangle, a sphere, or you can select a foreign body. So for this one, let's just choose the sphere for now. And you can see that you have a box on the side here that says the radius, and you can see in blue the body that we're using. So if you double click in this box, you're actually able to change the dimension. So right now it's 10, I can change it to 15, and you'll see the whole sphere changes. I can change it to 50, whole sphere changes. Now I'm going to just put it back to 10 and leave it there, but you're able to select the shape and then just modify it just by using this box here. So now let's move this sphere into position where we want it. So let's pull it forward, and let's look at it from the front, and let's pull it to the side there. Just bring it back a little bit. And you can see that the yellow is what is a preview of what we're going to get, and the blue is the original. And now let's just pull this straight up, and you'll see how both sides and our whole profile is changing. And as we pull it up, it's going to keep following it. And say we move this more to the back, you're going to see that the back area would actually move up too. But we want the front, so let's bring it to the front. And let's just bring this down just a bit. And now we have that profile that we wanted. So now let's click OK. And now using the deform, we have the profile that we wanted. Now let's do another one. Let's delete this deform. And this time let's deform the whole object. So last time we only picked these three surfaces to deform. This time we're going to choose the whole object and we're going to deform everything. So let's click Insert, click Features, click Deform. And for deform regions, let's select each face on the object. And then just choose the whole object for the surface body. And the push direction, let's choose this line here. And let's make it going forward. This time, let's choose and ellipse as our object. And again, you can see that we have this box and we're able to change the dimensions in it. So you can change this to 10, change this to 5, change that to 5. And you can see that in the blue outline we've changed, again, the object that we're using to push and deform into our original. So now that we've changed these dimensions, let's move this around, and you're going to begin to see the deform that we're getting. You can see on the side there, and as we move it up, that deform's moving up. Now let's make this bigger so we get a larger deform. So let's put this back to what I had it before, so 20, 10, and 10. And now you can see that the deform is much larger now that we've changed the size of our object that we're using. And let's just keep pulling this straight out. And as we pull it out, you can see that the surface is being deformed as well as that one. And it's only being deformed in the one direction that we specified, so it's being pulled this way. And say this is what we want, we like it, let's click OK. And now we have another deform. So this tool allows you to take a shape in an object and kind of push it into the surface. So this is kind of like using sheet metal in this little part here, and by using the deform feature on a sheet metal part, you're able to kind of put like an indent that you would want. So if you need it for clearance, if you need it for strength, you're able to kind of just use the surface push feature to indent that shape into the sheet metal. And you can also do this to just normal solid bodies, just to give it either a shape that it needs to have for clearance or aesthetics. So again, with all the kind of the deform features, it's more artistic, and it allows you to kind of play with it and mold it and just make it look and appear how you want it to be. And this concludes our tutorial on the surface push deform feature within Solidworks. This is tutorial number 163, and it covers how to use the surface push select body feature within Solidworks. To start off, open up tutorial part number 163, which is located on the DVD. Now in the prior tutorials, what I've covered with the surface push is that you have a body selected through the drop-down menu, and you use that body to create a deform. Now in this tutorial, what I'm going to do is you're also able to select a body that's created outside of the whole menu and use that body to deform your feature. So what we're going to be doing is using this body up here that I've already created beforehand, and we're going to use this to push into the surface and create our surface push. So to start off, let's get into the deform feature. So click insert, click feature, click deform, click surface push, and from the drop down menu you have the select body feature, so click that and then select this body here because we're going to be using this to push into our original object. So click it, and now if you move it around, you can see that we have that blue body, that blue kind of like display of the body that we're using to push. So now let's use this push feature. First, let's do one pushing to make that profile like we did before. So let's choose this face, and this face, and we're going to make a profile that goes around somewhat like that. We'll choose this one as our whole body, and for the push and pull direction, we'll use that. Now let's move this guy around and just see what we get. And let's pull this straight up. Now if you compare this to the one that we did before, it still has kind of like the same height that we used when we did the sphere, except it tapers off a lot quicker and a lot steeper going down. So let's click OK, and we've got one surface push using that feature at the front there. Now let's delete this one and let's do one on the whole body again. So let's click Insert, Feature, Deform, and let's choose every face on this object here. And then select the body. And for pull direction, let's make it go this way. And let's just flip the direction. And we're going to be using this body again. So let's pull it down. And let's move it around. And you can see the push that we're getting through this object. Now, one of the reasons you would use this is in, say, like a sheet metal part, so that you get the correct spacing that you want for that actual object to get into. So in this case, say that this was something like a battery, this little object, and say that we need to push it so that that battery has enough room to get in. So you can see that as we're using this object, we're actually making a cavity that's going to fit for that object. So that's one kind of application, that using the selected body that you choose, you're actually able to create an indent that your original body would be able to fit in after. So you're able to, kind of like tweak it and just play around with it to get exactly what you want. But that's kind of one of the ideas of having the surface push when you select a body, is that you're able to push that body out, and then later on, if you have an assembly or whatnot, you can actually put that body into that cavity. So, it looks like we kind of got that cavity. It's not all the way down as far as we want, but if you look at the top, the view, it looks like it would fit in there. So let's click OK. And now we have that cavity. So if that body in an assembly we wanted to put in, you just drop it down. And then after, when you finish creating your surface push with that body, all you have to do is just hide it, and you don't have to see it in the assembly anymore. Or, sorry, in the part. And that concludes our tutorial on how to use the surface push selected body feature within SolidWorks.